Good morning, everyone, and welcome to the first Europa Village session. Bonjour à tous et bienvenue dans Europa Village. Today we will host 5 projects. You can see the logos here, and more projects will present tomorrow and Thursday at the same time. And I will have the honor to moderate the Thursday session again, so I hope you will attend on Thursday. A few words before we really start. Well, first of all, let me introduce myself. I'm Pascal Bernier-Brunner. I'm the communication manager at ETP4HPC. Now, ETP4HPC stands for European Technology Platform for HPC, and we are a non-profit association that promotes European HPC research. We have more than 100 members from industry and academia. 40% of our members are SMEs, but we also have all the large vendors and the large HPC centers. And we are a private member of the EuroHPC JU, where we have an advisory role. So concretely, what we do is that we propose research priorities in the area of HPC technology, and this is used by the EuroHPC to define the contents of their funding programs. So it's very gratifying for us to see the actual funded projects come to life and produce results in the domains that we recommended for funding. And if you want to know more about us, we have a virtual booth here at the Teratec Forum, so please visit us. Now, two practical information. This will be a fully live session, and we will try to make it interactive as we can. So feel free to ask your questions at any time in the question panel, and we will answer them after each presentation. Okay, so after each presentation, we have 5 minutes where the speaker will be able to answer whatever your questions you asked. And yeah, last word, this session is recorded, and the recording and the slides will be available on the Teratec Forum website. I don't know exactly when, but they will be available. So let's get to the core of the session, the agenda. So our first speaker
So is it only me, or did we lose Pascal?
We lost Pascal.
Okay, so I don't have to be in hectic mode to put on networking cables. Shall I just start?
I don't know.
So perfect.
Yeah, maybe you can.
I can try to hijack everything now. My screen. So I hope you can see now my screen.
Yes.
Yeah,
that's good. It's a perfect start. Stress test at the beginning. Okay, so for the audience, I just decided to go to hijack the session, as I think we have quite a tight schedule, and I'm quite sure Pascal will be back as quick as possible. So I was invited to give an overview or a short dive into the EuroCC project. And if you see, let's say, the slide, it has also a sidekick project, which is called Castiel, and both together have been seen as let's say, like one big activity. So that's why we'll give you some information on both of them and just give you, let's say, some more background on that. So if we look at the European HPC strategy, you maybe have seen already in diverse versions these kind of 3 pillars. One pillar is the infrastructure, one is the applications area, and one is the technologies area. And we have, let's say, in the applications area, we have a variety of activities with regard to the centers of excellence for certain domains. In the area of infrastructure, we have Praise, Géant, and other activities. And in terms of technologies, we have, for instance, the EPI, which is developed, modular architectures from the deep projects, etc. So there's a variety of things going on here, and I think it's pretty interesting to see. And I apologize already if I just forget the project of your interest, so it's not a complete picture. I just put together what was there on the table. But we all see that there are a lot of things ongoing here, and with the EuroHPC joint undertaking now in place, this all has been combined, let's say, and quite more structured to follow the European HPC strategy. And one bit of this, and I think this is one thing we all suffer from, is in several areas sometimes the competences. And the competences are the baseline for everything, which means for the people we employ, the competences for providing services, etc., in the different countries. So there was an idea to think about, okay, what do we have on European level and what do we have on national level? So on national level, we have national infrastructures, we have applications which are developed by national stakeholders, we have training on national level, we have diverse activities, research, knowledge, etc. And all on the national level is always really depending on the strategy of the single country here. So we have some countries which have, let's say, invested a lot of money into their respective HPC strategy, but we have also a lot of countries which did not have the money yet available or did not see yet the need to invest in that. And this gives us some sort of an imbalance in terms of maturity, and I will come to this in some seconds. On a European level, it's quite like a mirror here. We have European infrastructures now, let's say, being much more expanded with the pre-XScale systems and the petascale systems. We have European research, we have the centers of excellence in the applications, we have technology platforms, other strategic activities, etc. And both these levels exist somehow. And often there's just, let's say, a competence available and the competence feeds back into a country if by chance a partner in this country is part of one of the European consortia and vice versa. So at the end, the question was really, okay, how can we do some sort of what we call the level glue, put something in between, which allows us on first hand that the national level can continue the national strategy, but benefits also from the activities of other nations, and how can we combine this and maximally use the synergies on a European level. And so this was when the EuroCC idea was created, about really making a big attempt to now establish in each participating country, so we have 33 countries participating in this project, a national competence center, which is a single point of contact towards the world of HPC in this area. We have to be realistic here. The NCC is not automatically the same as, for instance, a supercomputing center, etc., because it has much more outreach and it covers much more activities. I will give you some example how an NCC can be structured in the next slide. So at the end of this activity, EuroCC and the Alliance Castiel, the idea is really to set up the frame for delivering services, innovative services, and to really show how the users in the respective nation can benefit much better from this established structure and have much easier access to knowledge, expertise, and provided competences here. So if you look at the NCC, what could be an NCC, and this is just a schematic part here. So what we say is the NCC is a frame which is set up. In some countries, it's part of a, let's say, combined of a certain number of participants. Sometimes it's only one participant per country. This was decided by the nations themselves, whom to send in. And what we see is that they bring together the national ISV software developers, the HPDA and AI experts. So we're not talking about plain HPC, but also, I think I mentioned this before, HPC Plus, which is HPC and associated technologies. So technologies we use in the workflows to improve services. National HPC training stakeholders should be integrated, national resource providers, and much more. And the idea is really to provide a sort of what we call the competence mapping, so that we get an awareness of what is available in the nation, who are the players in the certain activities, and how can they be brought together to provide services. And let's say the consumers and stakeholders of these services are coming from science, industry, society, and politics. And bringing all these things together in a certain frame is already a challenge, which is now running for the first 2 years. So then we have the Castiel project. As I said, it's like the sidekick or the little brother or sister of EuroCC. So this is the one which really works on the European level. So in EuroCC we have classical work package structure, 34 work packages, one management work package, and 33 work packages, one per NCC. In Castiel, we do this kind of integrative work packages where we set up also here a frame how they can exchange the information. So what we did here is that we said, okay, we have a different level of maturity, we have the diversity here, and we want to bring together the nations and make them aware of one thing, what is happening in another nation, on the other thing, what is happening in Europe and other activities. So it's like a support of information flow, but also support of exchange and support of elaborating synergies. So that's why we have decided here to enable different activities. One thing is a single access portal, and I know it's always like every project does some sort of single access portal. We are quite nasty and now started discussing with existing portals. So in a way that we can find a frame how we can integrate our things in their bits and the other way around, so that people don't have to jump from 3 portal to another portal, but really can have direct access to the information. What we do is the competence mapping on national level, and it's taken up by the Castiel project on a European level, also like a knowledge base. We have working groups activated in Castiel, which are working on training, mentoring. We are working on business development here, and awareness creation, etc. And these working groups consist of 1 stakeholder per national competence center, or let's say representative. So it can be a representative and a deputy, but they should bring in the needs and the requirements from the NCC. This is the important part, that the thing is driven by the national competence centers. And it's not vice versa, that Castiel has some good ideas and everybody has to suffer from this in Europe, but the other way around. Obviously, there was a starting phase where Castiel was providing some baseline to trigger the discussions, but now it's the way that this input is taken up from the NCCs, and also the processes and mechanisms are, let's say, much more finer reshaped. There was, let's say, the diversity of documents set up. We have a training matrix, which also includes the other training, which is available, for example, through PRAISE, Centers of Excellence, etc. And there are workshops ongoing where the different NCC stakeholders can meet each other, or can meet, let's say, vendors. They can meet different technology owners, or let's say the joint undertaking to provide input to certain ideas. They can meet the Digital Innovation Hub. So it's really here to support them, bringing them together and elaborating on these synergies. So just some facts and figures here. The first phase of both projects runs now for 2 years. It started on the 1st of September 2020, so we did not have any face-to-face meeting yet. I'm really looking forward to this. But we figured out how, let's say, flexible online tools are by having more than 100 or 200 participants in a phone call. That works well. As I said, this is EuroCC access portal. At the beginning, we had 2 project websites for each project. One, we decided to bring them together in 1 portal, and the 1 portal will not be like the project website per se. There will be some information about the project, but at the end, it should be this information base for everyone. And this is something which is a living document, a living activity, which is, let's say, constantly extended by success stories from the countries. Interesting articles, different statements, etc. So it's always worth to have a look at this portal to see what's new and what's happening here. There's a focus, as I said, for these 2 years now on those commonalities. I already mentioned some of them. So training and skills development, technology transfer, business development, it's industrial collaboration, competence mapping, facilitation of access to the expertise and the knowledge boost, and also awareness creation. These are, let's say, the commonalities we identified when structuring the project. If we see a need for something else, we'll implement this. But I think from our viewpoint currently, we're quite fully staffed with these fields, and see already the progress which moves forward here. So as I only had 10 or 12 minutes, I will conclude now, and then let's see what your questions are, hopefully friend questions. So the mission is really to explore the synergies between the nations. So the idea is, you could always say something like this: okay, the nation wants to do something in AI, and then good luck. But it's much better if you have the support from somebody else who has already implemented such services, and to learn from them. The other thing is that we see that we also want to have this transfer. And when I said training, mentoring, we are also supporting exchange of people. So at the end, what we can see is, for instance, if a country wants to set up an activity in a technology field and doesn't have the expertise there, they will work on setting this up. But instead of just waiting until it's there, they might, let's say, ask somebody from another NCC to come there and to support them in providing the service already now, or they can, let's say, collaborate here. So there's a plethora of possibilities to really work together, and at the same time setting up and increasing the maturity of services. So the idea is really, if we are successful with setting up these NCCs and then the European, let's say, exchange level, then we can further boost the use of HPC in Europe, especially also in these countries were not so dominantly supported yet in terms of the strategy. we want to create success stories. So this is the most important part. To be convincing for your funding agencies, everything, you need to see what the successes are. And also here people can learn what their local industry might benefit from when you, let's say, establish certain services, etc. That's the perfect thing. Also, we want to give the guidance, obviously, to the best use of utilization of the new systems which are there now, the PETA, pre-EXA, and later the exascale systems. And the important part here is also that people understand it's not only about setting up something like, here's a machine for industry, but the question is really, how do I talk to industry? How do I interact with industry? And there's some countries have a good history in that, and by that are able to provide these information to those which are just newbies and would have massive problems really getting an interest from the industrial side. And by that we much more strengthen the single nation in Europe at the same way, let's say, putting this under European umbrella, and at the end fulfilling, let's say, and providing a competence baseline for Europe, which will, let's say, support really the standing of Europe in this HPC area worldwide. And that's pretty much it. The good thing is if you have, let's say, 36 nations in a project, then it's perfect to have a disclaimer because it fills one slide all. Thank you very much, and I'm looking for your questions, and I hope I was in time. And Pascal, you're back.
Yes, you're right on time, and I'm back. I'm sorry for the interruption. Obviously, I lost the connection. I don't know why. Maybe we have a big thunderstorm here, so maybe that's it. So, can you stop sharing, and I will share the agenda while we answer question. Okay? Probably missed the agenda. I don't know if I was already sharing it or not when we lost the connection. Anyway, so please, if you have questions to Bastian, ask your questions, and I will start. I have one question for you. It's about the relationship between the two projects, because you talked about EuroCC and Castiel. So Castiel is a coordination and support action for EuroCC. What does this mean? Does this mean that the 6 partners of Castiel decide what the NCCs have to do?
That's what always people are scared of, obviously. There's nothing like megalomania that you think about telling everybody what to do, but it's the other way around.
Okay.
So the important part is really somehow that the Castiel had to make a starting point somewhere, some initial ideas, providing them for discussion there. But obviously it's the NCCs, and that's why we have these working groups where each NCC has a representative there at least, and they are the ones which have to bring in the feedback. So being bluntly honest, obviously, if they don't say anything, they're doomed. Yeah, and
okay.
but we have a lot of good discussions already there, and it takes some time, obviously, until all people are brave enough to really bring in their ideas. And this is one cultural thing which was important in this project, that everybody can bring in his or her ideas. Obviously, for some people, things are trivial, which are not trivial for others because they're not since 10 years working in that field or have not made experiences that others made. But we had a starting phase, obviously, of this. Officially everything perfect from the beginning on, but being honest, I see now how the group comes together and how more and more people really bring in their desires, and that's the important part. The coordination support action is for the people they support. It's not about, let's say, just coordinating them and telling them what to do.
Okay. And we have a question from one of our speakers, really, from Erwan Raffin. Do you have any success story to share already, or is it too early in the project?
We're getting now the first ones in. So obviously, again, just some advertisement. The EuroCC Access Portal will have them on board. What I can say that we also, let's say, are now more, let's say, opening this with the JU to make this really in a combined way to advertise the success stories per NCC in a regular way. There were several activities. One activity is from the Swedish National Competence Center, which was working strongly together with the Vega Consortium, and we see now bitwise. And also here the success stories will be quite different in terms of the diversity. For a country like Germany, let's say, if you say, okay, we talk to industrial user, it's rather, yeah, we do this since years. But for a country which has not done this so far, but does first experiments, this will be a strong success story. And this will be, let's say, we try to we'll also label this in a way that it's clear that these are really the successes here. And obviously, we supported also the NCCs now to bring in first proposals for the Fortissimo for EuroHPC activity. The open call one was closed, and there is a variety of countries. I don't know if I think 14 or 15 different countries have brought in things, bids. They're partially with the NCCs, partially without them. There will be a new call now, so we will also support here much more massively that we have a widespread over Europe of these experiments to also ensure that the small countries and not so experienced countries have a chance to get some funding here to really boost the bids in here. So yes, success stories are manifold. As I can only say, just look at this portal, best portal ever. Maybe I have to say this.
Okay, we'll visit the portal.
Yeah.
Thank you. I don't see any other question coming in, so I think we will switch to our next speaker, to Erwan Raffin, who will present Easy Ways. Thank you very much, Bastien. And we can't see you, Erwan. We can see your presentation, but not you. Here you
Should
are.
be better now.
Okay, so yes, and remember all the projects who are presenting today, they have a virtual booth in the Teratec Forum. So if you want more information, if you're looking for contacts, please visit their booth in the exhibition. So, Erwan, now that I am back, by the way, thank you, Bastien, for stepping in when I suddenly disappeared. So, Erwan, welcome, and I'll leave the floor to you. You have 12 minutes to explain what is Easy Ways. Thank you.
Thank you very much, Pascal. It's a pleasure for me to present you today the Easy Ways HPC services for weather and climate models towards production-ready simulations on European exascale systems. The Easy Ways is the Center for Excellence in Simulation of Weather and Climate in Europe. It's big consortiums. The first phase lasts from September 2015 to August 2019. And we are now in the second phase of the project, which already started in the 1st January 2019, and it will last until the end of 2022. The coordination is DCAR-Z and ECMWF. So we have 20 partners in this consortium from 9 countries for this phase 2. So you can see here most of the main, all the partners, and the different. You can see that there's some HPC centers, but also some people from academia and from industry. So inside the Easy Ways 2 project, we have different goals. The first one is really to push the limits of the models in extremely high result simulation, which is now the main focus. The main focus on the project will bring a lot of advantages in terms of forecast, and also to ease the porting of the models to different new hardwares using domain-specific languages. Also to provide HPC development services to modeling teams, and this is the focus of this presentation today. Another goal is to develop new infrastructure for storing model output, because the data issue or data wall is really something that the community, the weather and climate community, face on a lot. Also to enable visualization and analysis of the vast amounts of data produced in the high resolution models. It's really important to be able to visualize the output of the models and to be really able to show the outcome of these simulations. Training of the young researcher is also one of the main goals, and to foster collaboration of technical experts, both from academia and from industry, and also from different HPC centers. So I will focus a little bit today, as explained, on the HPC user services. This is really an important pillar in this project, in this center of excellence, because it's really a way to really focus on the different issues, the different problems that are facing the community regarding HPC, software, hardware, And this is really an open HPC service call to all the modeling community, to the whole modeling community in our system in Europe. The idea is to create some short-term collaborations to provide guidance, engineering, and also advice. The idea is really to have a good impact and a long-lasting impact on the source code of the model, and the main goal is to improve their efficiency, their performance, because performance is really at the heart of HPC. All groups that develops and maintain weather and climate models can really be part of this HPC user service code. So proposals are peer-reviewed by 2 steps. First one is really a technical one, just checking that it's feasible technically, I mean, and another round about scientific peer-reviewed to really grant the best project proposals. So if you are developing a weather climate model in Europe and you are looking for guidance, engineering, advice, you want to boost your performance of your model, you want to prepare the future for the next platforms, such as GPU-based HPC systems, then please submit an application to the next call that will be released at the end of this year. Here in this slide, you can see the granted project for 2020. We had 4 projects, one called FISM2, which deals with global sea, ice, and ocean circulation models. The idea was to do a first port of FISM2 on GPU using OpenACC. The EMAC, which is the second project, was about improving the efficiency of a CUDA version of the code, especially on memory aspects, memory consumption. The DALIS is the third project, the Dutch atmospheric large eddy simulation. The idea was really to focus on performance, on thermodynamics code especially, and also to investigate the use of single precision. The last project called OBLIMAP2, which was about fast climate model, ice sheet model coupler. The idea was really to parallelize this code using the MPI shared memory and MPI distributed memory paradigms. And also to implement the parallel net CDF read write IO. This code was running on a single node only, and the idea was to move really to a multi-node approach. Here you can see the success story of this OBLIMAP project with efficiency in terms of use of memory. It was even not possible to use a single node equipped with an AMD, 2 AMD processors, so a total of 128 cores. And also you can see that we obtain a nice speedups around 4.4 between the original version that was able to run only on 1 node up to a 4-node run here with 512 processors. So a lot of publications have been published on the different projects, service project in 2020. Now you can see the granted project for 2021. We are currently working on it. FISM2 again asked for a support for really improving the first version of the OpenACC. And as FISM2 is an important model in Europe, they have been granted another round as DALIS. Because there was plenty of room for improvement again on these 2, and we have 2 newcomers, EGRIF, which is like a Zoom for NEMO, for example, which is an ocean model. So it's an adaptive grid refinement in Fortune. We are working in the profiling and the performance of this adaptive grid refinement tool, and also on the RT MGP C++, which is an interface for the radiative transfer for energetic and rapid radiative transfer models for GCM applications parallel. So the idea is really to boost the performance on GPU to really take advantage of the new architecture, for example, A100 GPUs from AMD. That's it for me. Thank you very much for listening. I hope you enjoyed my presentation and you had all the information you need, and now you're ready to submit your proposal if you are developing and maintaining a model in weather and climate in Europe. So if you have any question, please feel free to ask.
Thank you, Erwan. Any questions? Please remember to enter your questions in the questions panel. I had a question for you. You detailed different projects, different HPC user services projects. So how long does this collaboration last? I mean, for an HPC service project, how long does it last?
It lasts 1 year, and there's a 6 person months effort corresponding to this 1 year project. So if you ask for the call out at the end of this year, 2021, we will work with you in collaborative way during the 2022 year, full year, and the effort corresponding will be 6 person months.
Oh, that's
for each project.
For each project, wow.
Yeah, this is in kind. I mean, this is proposed, offered by the EasyWays, and we are 2 partners working on it. ATOS, the Center for Excellence in Performance Programming, and also the eScience, which comes from the Netherlands, which also have expertise on HPC, GPUs, AI, and we have really a wide spectrum of expertise to help developers to really take advantage and boost the performance of their model.
Okay, thank you. We have a question from Henry Strauss from SICOS. How does your project compare to Accelerat?
Oh, this is a good question. I won't go too much into detail, but Accelerat, yes, is also a good example of a collaboration that can be brought to the community. I hope we'll be able to exchange a few words about this with the consortium, but difficult to say today. I'm not sure if when will be presented Accelerat, but the idea is really, yes, to really broaden as much as possible the expertise from the different partners inside the consortium. And Accelerat, as far as I know, is really in the same sense, in the same way, providing really expertise. But it's more on co-design and I'm not sure, but the EasyWays is really targeted the weather and climate community, especially. Yeah. So it's maybe the most important, the most important difference, I guess.
Yeah. Yeah.
I guess.
Okay. Well, thank you. Henry Strauss, did you have something specific in mind when you asked the question, or is that all right? Because it's, I mean, I'm not sure it's fair on, I mean, Erwan is maybe not aware of exactly what Accelerat is doing, so.
A bit, at least.
A bit, at least? Okay.
Yes, but I know that it's really, promoting the expertise, and it's like a point of contact to really propose there, so the expertise to different communities in HPC.
Okay. Any other question to Erwan? We are ahead of time, so. No, okay. The answer is sufficient. So
please feel free to contact me offline if you want more details about the overlapping between the 2 projects, but also how we can maybe exchange some good practice, methodology, or any kind of information that could be interesting. Sure. Okay. I'm not sure if Pascal is still here, so I will just stop my screen sharing and let the floor to the next speaker.
Okay, next speaker should be me. So probably I should start to share.
Yes, please step in.
Can you see that presentation? I'm seeing it on my side, but I'm not sure everyone sees it.
Not yet, me.
So let me try again. Okay, let me try again. It's very slow on my side.
Sorry. I seem to have disappeared again. I don't know what's happening today. So, Marc, can you share your slides?
So I'm sharing my screen right now.
No.
No. You should see it now.
No, oh, yeah. Now we see it.
Okay, but do you see the presentation? Because there was
we see the presentation.
Okay,
yes, we see Lexis. Okay.
This is great. Okay, so I'm Marc. I'm also from Atos. I work in the HPC software R&D division, and for Lexis, I am the work package leader for co-design and let's say it quickly, overall system architecture. Lexis is a federation of the Lexis platform is a federated platform that is hosted by several resource providers in Europe, like IT4 Innovation in the Czech Republic, LRZ in Germany, iCheck in Ireland, and also we have data providers, for example, for climate and weather data with ECMWF, and there's potential for extending the platform, and the goal is at the confluence of HPC, big data, edge computing, and IoT, and we are trying to explore the ability for such a platform to host more and more complex application workflows that I'm gonna describe in the next slides. So the key points are, first, to be able to handle dynamic and complex performance, big data or hybrid workflows using orchestration systems and that are potentially capable of dealing with sequences of different kind of application and even real-time deadlines for some of the use case that we'll describe a bit later. We have a cross-site data and metadata management reusing some UDAT services that have been developed in other European initiatives and based also on the IRODS technology for distributed data management and data discovery. We also have different storage layers, including storage accelerators like bus buffer nodes, and also some data operation accelerated with GPUs and FPGAs. We have developed a web portal dedicated to that platform to ease the access and streamline all the user actions, which can be pretty complex. So the goal is really to simplify everything that the end users have to see and do. It is also based on a single security model that has been distributed to the entire platform. So all the service and data providers are connected to a single security system that is zero trust, and that we call the Lexis AI, and that we will describe also a little bit deeper in next slides. And the idea is to simplify the access to HPC resources, also providing a cloud layer. So we try to have to mix the best of both worlds for SMEs and industries in general. to make it a sort of a big data and HPC for everyone. And so the main goal is to first be able to handle big data for very large simulation, and those data are distributed across all the participants on the platform, resource and the data providers, which are mostly HPC centers that team up together to join their forces through a unified security model that uses federated security and zero trust that we call the XCCAI. Then we have the notion of data curation. For example, our partner ECMWF provides weather and climate data that is curated data, and that can be used in certain and moderated in certain conditions. We have data management, data sharing, and data valorization, reusing those UDAT over iRoads services. Then we have cloud and HPC hybrid workflows handled by a technology called EuroCC, which is a meta orchestrator that can orchestrate workloads across different kind of infrastructures and over several locations, and also a middleware called HPC, which is both security, a middleware that grants secured access for users on the cloud, the Lexis cloud part, but also to the HPC part, while sticking with very high security standards, especially when it deals with the HPC parts, which are protected parts in all HPC centers. Then we have a fine accounting and billing engine provided by our Cyclops partner that is seamlessly integrated in the portal. And last but not least, we have the goal to provide all those services and for a pretty diverse set of use case in the form of HPC as a service for the current partners that we have and the new ones in the future. So our main, our three pilot use cases are focused on aeronautics, earthquakes and tsunamis, and weather and climate. And those are intended to help us guarantee that the platform will be able to support those diverse use cases, and also because they come with pretty different kind of workloads and objectives and KPIs that will be normally enough for us to make sure the platform will reach the goals. So the first one is about focuses on computation fluid dynamics, CFD, for rotating parts like gearboxes and other kind of parts and applications. And they'll do also a lot of 3D visualization. About earthquakes and tsunami, it's about prediction models, databases, and the organization of emergency measures, which will induce urgent computing, which is quite a challenge too. And weather and climate workflows were centered on high performance computing on the WRF solvers, on which they hook a very large number of pre and post processors for different kind of use case for agriculture, the handling of wildfires, floods, and other like that. So very diverse set of application use cases. I will accelerate on this one, but here on this slide, and I will leave the slides, you have a few more precisions about what exactly those teams and partners are looking for. One important component in the architecture is the how to integrate those very complex pilot workflows on the platform, and for that we need a workflow definition engine, which is based on the Tosca language, and that comes as a plugin for the York orchestrator. So here you have representations of all of how complex those workflows are, and knowing that all of these little boxes correspond to one application or one preprocessor or one post-processor, or data transfer, or a more heavy simulation phase. Here we have little clouds showing which parts are executed on the cloud layers of one or the other HPC center in the federation, and the red one shows the parts that execute on a real HPC infrastructures. An overview of the federation as it is today is proposed here with a snapshot of the kind of infrastructure we have on the three sides. So iCheck in Ireland, LRZ in Germany, as we said, and IT4 Innovation in Czech Republic, where we can have similar infrastructure, but also with very specific, let's say, servers or specific nodes or accelerators that can be different from one side to the other, or backend file system, HPC file system that can differ. So all those centers may have made different technology choices, and then we have a certain complementarity between all those centers. And you can see on the left ECMWF, who acts not as a resource provider, a computing resource provider, but as a data provider for the climate and weather use case. And you can see that all those big blocks communicate through different kind of APIs. Can be iRods for distributed data, can be WCDA for curated weather and climate data processing, and over the Géant network for internal communications in the Lexis Federation, but also connected to the internet for the access from end users. We also are in the process of hooking some edge capabilities for the climate use case using what we call smart gateway devices to acquire local data from weather stations, a large number of them. So the orchestration is mostly based on two components. The York, which is the meta orchestrator, which knows how to orchestrate workloads on OpenStack, for example, YAS that are present in all our HPC centers as a front computing end to before reaching the HPC parts. So some of the workloads can run on those cloud parts, and York is able to dynamically optimize the placement of those workloads and execute and provision the right resources to execute those tasks, and also has the ability, when an HPC cluster is needed, to through the HP security middleware to address to place that workload on the HPC cluster. And we have another API, Alien for Cloud, which is a plugin to York that offers a catalog of all the application workflows that we have already created for the 3 use cases, pilot use cases that were described before, and has been also the Alien for Cloud capabilities also have been seamlessly integrated in our portal, and it comes with a REST API. So about distributed data infrastructure, this slide shows that actually data and infrastructure for data operates at least 5 levels. So it starts with the collaborative and federated data layer that allows a seamless distribution of data and secured and resilient distribution of data across the HPC providers. Then we have, at each HPC provider, we have object storage, file storage, block storage that can be deployed and put under the control of the upper layer. We have like also a regular shared file system using NFS, and then we have more low-level and faster, more HPC like parallel file system like GPFS and Lustre, depending on the HPC center. And then we have near RAM kind of storage and data acceleration using NVMe technology, also named burst buffer nodes.
I'm sorry to interrupt, Mark, but your time is up. So can you please quickly wrap up?
Yeah, so I'm almost done. So this is the last main part. It's the federated security. So Lexis has implemented security by design. So security has been part of the co-design activities from the beginning. Nothing that runs on the platform is trusted by default. So every service authenticates and checks their credentials and their to that central AI. The central AI is also distributed, so it makes it resilient. So we have high availability, and it implements most of the state-of-the-art identity federation, authentication, and role-based access technologies such as SailMole2 or OpenID Connect, and all this is based on the Keycloak SSO tool. Next slide is another view of what the data, distributed data infrastructure brings, mostly what we call FAIR attributes, findable, accessible, interoperable, and things like that. We have monitoring and billing APIs that also consume data. We have a data transfer API. We have mostly everything that blurs the frontiers of data management across the federation. And the final piece is the web portal that is hopefully the only thing that the end users will have to deal with, so that they don't care about the complexity of the entire platform. That would be totally out of reach of most users. So here you have a few of the views, including a view of the active workflow. And the last part is that we also have seamlessly integrated 3D remote visualization capabilities using the HTML5 protocol that allows to pre and post process very large 3D data without transferring the data back to the user's workstation. That's my last slide, and I'll be very happy to answer questions.
Okay, there is one question from the chat. So we will, if we can handle this quickly. How do you manage the softwares and codes necessary to do simulation HPDA between the SMEs and HPC cluster? Do you have collaboration with ISVs and code developers? It's in the chat.
Yeah, absolutely. So we do both. We cooperate with ISVs. For example, there's a commercial ISV involved in the aeronautics use case, and they help us putting in place the licensing parts, for example, which can be sometimes a bit tricky, and also make sure that everything is in place so that some of their workflows are complex and we need the software vendor, especially with very new software, we need their support to make sure we have integrated everything as we should. We also work on some of the codes of other use cases on our own. So some of the partners do develop, and also have other partners outside of the Lexis project who also, for example, bring some skills or maintain some part of the code. So yes, that's a pretty complex ecosystem. And the last thing I would say about that is it's it's made a little bit easier using containers. So sometimes some of the workloads can be delivered in a much simpler way when they're containerized.
Thank you, Marc.
Thank you very much.
Can you please stop sharing, and we will now, thank you very much for this presentation, and we will now have Ligate to present this project. Silvano Coletti, are you here, Silvano?
Yes, yes. Let me share my screen. Do you see my screen? Do you see? Do you see the screen? Hello? Hello? Did you see my screen, Pascal?
No, I can't see your slides.
Wait.
But then I had an interruption once again, so you know. It's
Okay, let me check again.
this is not your slides, but
Let me see.
yeah.
Okay.
Excellent. Thank you.
Okay, thank
Go
you very
ahead.
much. So, yes, thank you. Good afternoon. And thanks to Teratec organization for giving us this great chance to introduce the Ligate project that is a public-private consortium funded by EuroHPC joint undertaking, and from nations participating as Switzerland, Italy, Sweden, Austria, and Czech Republic. So let me introduce myself. My name is Silvano Coletti. I'm the executive director at Kelonia, known as Kelonia Applied Science. That is a competence center based in Basel, inside the innovation office of the University of Basel. And in Ligate, we are leading the work package for dissemination and exploitation in tight collaboration with the project coordinator Dompe Farmaceutici and all the other members. So Kelonia is the window basically to enter the world of excellence, breakthrough innovation. We have in Ligate project, but also in the partner project Escalate for COV. I put some useful and official links here in this page. Ligateproject.eu is surely the window to enter the Ligate with all the information. And also I put the logo of a podcast that we started a few weeks ago, and that you can find on all the platform, and where you can find also some interesting interview to the Ligate members. Now, just few words to introduce the Ligate in the right framework. So the domain I'm going to introduce today is related to the drug discovery and to the exploitation of supercomputing resources available here in Europe. Drug discovery is basically the first step of the value chain that identifies new candidate therapeutics for treating or curing human diseases. It is the initial stage of biopharma research and development, and involves the identification and optimization of potential new drugs and the preclinical in vivo validation through cell assays and animal models. Successful candidates that meet the regulatory requirements applied to the drug discovery move into the clinical trial phase, where they are tested for efficacy and safety in humans. And here we are with the project. So you understand that the drug discovery is a very long and expensive, often unsuccessful process. You have to think that the average time to discover a new drug is about 10, 12 years. And one of the factors that reduce the accuracy of the discovery process is rightly the lack of precise knowledge on the three-dimensional structure of drug compounds and target. Their binding affinity, so what we call technically the specificity and kinetics, are ultimately what determine the efficacy of action together with the efficient drug delivery. In this framework, and I would say also strong of the success that we are achieving in the partner project Escalate4Cov, last January first started the project Ligate, composed of 11 partners from 5 European countries. The partners are Dompe Farmaceutici, Politecnico di Milano, Cineca, KTH, Royal Institute of Technology, Università degli Studi di Salerno, University of Basel, IT4Innovation National Computing Center, E4 Computing Engineering, TOF Motion, University of Innsbruck, and Kelonia Applied Science. Here I reported a quick overview of the software that brought to Ligate. So Dompe Farmaceutici started to invest in the drug discovery platform since 2010 in a proprietary software for computer-aided drug design. The most relevant tool is the novel structure-based virtual screening software Ligen, that means ligand generator, co-designed in collaboration with the Italian supercomputing center Cineca. Ligen, as a distinguished features, has been designed and developed to run on high-performance computing architectures, and to maintain the performance primate beyond 2020. Our main objective, I would say, is to port Ligen to accelerated architecture, regardless of specific accelerator hardware, and integrate it in a solution to allow to simplify the management of the whole drug design process. In order to be hardware independent, we will apply the most innovative and emerging technologies in new programming paradigms that are leading the transition to exascale computing era. In the Antarex project framework, a Ligen implementation ready for pre-exascale HPC application was developed by exploiting the knowledge of Dompe in combination with the excellence in HPC software design, development and tuning of the Politecnico di Milano, and the world-class competencies of Cineca in the deployment and optimization of extreme scale computer simulation. Following this trend in the Ligate project, we are planning to further optimize Ligen efficiency, scalability, refactoring, porting, and optimization to new HPC heterogeneous hardware and software architectures of increased supercomputing performance. At the moment, no automated industrial software solution is available for drug discovery, and so the main project ambition, let's say, of the project is to integrate this issue, critical issues, geometrical scoring, pharmacophoric scoring function, and molecular dynamic free energy estimation. I prepared here some slides related to the innovation areas from Ligate. Here, the computer accelerator drug discovery. We will develop a portable and tunable drug discovery platform. The platform will be based on Ligen, Geodoc, and GROMACS tools with an artificial intelligence engine for score prediction. The design of the computer-aided drug design platform will enable the exploration of exascale scalability. with regard to free energy calculation, so the implementation of interfaces to automatically set up, perform, and execute free energy calculation with GROMACS is surely at the top of the agenda for a Ligate project. The setup will generate a series of independent molecular dynamics jobs that are executed by the Ligate workflows, combined with tools for automatic analysis and calculation of the final free energies with standard errors. So now I'm going ahead with the different innovation areas, but I suggest to the participant to this of this presentation also to go really on our website ligateproject.eu, where you can find also the entire workflow with the different work packages. Regarding the programming models for code portability, I can say that Celerity programming model and runtime system will provide an high-level SQL-based platform to support all platforms targeted by the existing SQL implementation and which can be ported to a cluster of accelerator. And the Ligate project will provide a set of techniques to optimize the data transfer and facilitate enhanced scaling on exascale machines. Regarding the adaptivity and application auto-tuning, I can say that MARG2 auto-tuner developed in the Antarex project will be exploited for optimizing and improving the portability efficiency of the CAD platform. And the auto-tuning techniques will be based on machine learning during the HPC application lifetime to enable a degree of performance fine-tuning, exploiting full system capabilities. Hyperloom, so first of all, Hyperloom is a platform for defining and executing scientific pipelines in distributed environment. The main goal for us is to today compose a scalable and flexible pharmaceutical pipeline, mainly driven by benchmarks with Ligent and GROMACS, starting with benchmarking simple isolated parts and scale up to bigger workflows. The energy efficiency, of course, the fact is that the state of the art say that lack of simple programming models and runtime system that can automatically optimize for energy is a problem. So we are going with the integration of existing tools for more accurate energy measurement with Celerity's compilation and runtime system techniques to facilitate the enhanced energy efficiency. The HPC infrastructures, Cineca aims at deploying leading-edge HPC systems, including Leonardo pre-exascale system, and the IT4I that is operating the biggest supercomputing facility in the Czech Republic, will host the EuroHPC petascale supercomputer designed to support the complex scientific industrial workloads. So IT4I is also part of the LUMI petascale system consortium. Last but not least, the E4 infrastructures, so top-down solution based on carefully tailored design to enable fast discovery cycle is the state of the art. The innovation is that we will go with the co-design and deploying a small site, easy to configure and easy to reconfigure tailored solution that will enable the co-developer to test industrial software solution in the early stage of coding. I prepared the groundbreaking objective of the project. So we have provided the platform in the form of a highly scalable workflow. The resulting platform will be delivered as a complete workflow, and this allows us to scale up the solution on large clusters. Code and performance portability on heterogeneous accelerators. The main goal is to make the solution available on different exascale systems that will be deployed in Europe, including the one based on European processor and accelerator. The integrated automatic setup and execution of free energy calculations, starting from list of thousands of docket compounds, we will have interfaces to automatically determine compound parameters, set up free energy calculation in GROMACS, and execute the entire ensemble as a parallel run on HPC resources and return free energies with a requested standard error. The exploitation state-of-the-art artificial intelligence techniques to further speed up the virtual screening phase. The objective here is to exploit the possibility of generating a larger set of data to evaluate the possibility to predict the scoring function used in the early stages of the CAD platform and exploit state-of-the-art big data technologies for HPC to manage huge database and input-output. In this case, the large set of data needed by a virtual screening campaign requires a dedicated attention to the data management to avoid being the bottleneck of the processing. And the last is the platform to be a fully integrated industrial solution, integrating and enhancing best-in-class European software components, including open source and non-open source IPs. So thank you very much.
Thank you, Silvano. Thank you, Silvano. Quick question, because we're running a little bit late, only a little bit. Ligate, sorry, I was saying Ligate, but obviously I'm wrong, it's Ligate. So Ligate seems to be very ambitious. Does this project represent a game changer in the fields of pharmacological and medical research?
Yes, so as I mentioned before, because of the complexity of the nature, drug discovery is not anymore approached as a vertical discipline as in the past, but requests today a multidisciplinary approach. And Ligate prepares the unique suite of application ready to run on Escalate as leading platform, combining the power of precision medicine, artificial intelligence, extreme scale computing in a multidimensional solution to create novel drugs or doing repurposing of ones already available. So in Ligate, basically we respond to some still unmet need for whom working on drug discovery and AI. And yes, I know that probably we are late, but just let me mention the keywords of our project that are the code portability, the scalability, and the integration to be ready with our solution and leading player. Thank you very much.
Thank you. Thank you very much, Silvano. So I'm calling our next speaker. We will have Erwan again, but this time Erwan will be speaking for the VECMA project. So Erwan, so while Erwan is getting ready and sharing his screen, I just wanted to remind you that all projects presenting today are present in the virtual exhibition. So if you want more information, if you're looking for a link, I'm sure it's in their virtual booth. Are you ready, Erwan?
Yes. Can you see my screen?
Yes, we can see your screen. Thank
Perfect.
you.
Thank you, Pascal.
The floor is yours.
Okay, so let me now talk about VECMA, which stands for Verified Exascale Computing for Multiscale Applications. The idea of VECMA is really to improve your confidence into your numerical simulation results. So for the ones that don't know me, I'm Erwan Raffin. I'm from Ethos Center for Excellence in Performance Programming and part of this project. So here is an overview of the VECMA project. So it really deals with three pillars: the high performance computing, the multi-scale modeling and simulation, and the verification, validation, and uncertainty quantification. So let me introduce you a little bit the consortiums. You have a lot of diversity here, because we really target not only one specific application domain, but a wide variety of application domain. So we have the UCL from UK, we have the UVA from Amsterdam, Brunel from London, CWI also from Netherlands, we have LRZ from Germany, ATOS, IPP also from Germany, PSNC from Poznan, Poland, and CBK. We also some international partners as Rutgers and a lot of, let's say, associate partners. Let me just briefly introduce what is the VVUQ. So what you need to understand is that today simulations need to be validated, verified, and their uncertainty quantified, so they can feed into real life application and decisions. So as you know, most of the simulations are done by scientists to study the behavior of some physical phenomenon, but they also can be used to take the right decisions for a lot of different application domains. So what is VVUQ? What is validation, verification, and uncertainty quantification? So validation is is implemented to really determine if the model accurately represents the real world applications. Verification is performed to determine if the computational model fits the mathematical description, if the formulas are well implemented into the model. And uncertainty quantification is conducted to determine how variation in the numerical and physical parameters affect the simulation outcomes. So it's really a way to be able to have a real outcome from the simulation to the real life. The idea of the VECMA consortium is to provide freely open source a toolkit in order to easily perform VVUQ for multi-scale applications. So as I said before, we are targeting in VECMA a wide spectrum of applications. We have fusion from the Max Planck Institute of Plasma Physics. We have material science from UCL. We have biomedicine from UCL and UVA, migrations from Brunel University, but also full-scale climate modeling from CWI. And it's really applicable to any kind of application, even if it's not multi-scale. So the idea is really to provide what we can call it as the new reference as a European open source scalable toolkit for VVUQ. The idea is to really provide to the users, to the scientists, and to the decision makers a tool to easily validate, verify, and quantify the uncertainty of the model. So several tools are proposed. You can use it alone, or you can use it together to build your own VVUQ, let's say, tool chain. So FabSim3, which is a tool to deploy and to run the VVUQ campaign from your laptop to using an HPC an HPC system. Sorry, Easy VVUQ. It's really the heart of the toolkit, providing an easy way to deploy VVUQ campaign. So it's encode, decode, and run it on the HPC system. You have different tools to ease the deployment on HPC systems like QCG Pilot Job, QCG Now, and QCG Client. We have also like an API, common API, which allow to really let's say merge the two tools, Easy VVUQ and QCG Pilot Job, into one, and Merthel 3, which is a coupler. So really, as you can see on the tube map here, we have really different way to use it according to the needs. And you can really, let's say, deploy a combination of VVUQ from VECMA TK, VECMA toolkit, the different component in different way. So here you can see that more in detail, the toolkit, what it can provide. You create a range of VVUQ procedures using Easy VVUQ. Also to automate the different workflows of using FabSim3. You can also create a surrogate model for multi-scale simulation with Easy Surrogate. You can also enable the efficient execution on large system, as I said, with QCG Suite. QCG Pilot Job Manager, for example, allows you to execute a large number of jobs inside a simple allocation in terms of resource allocation into the HPC system. Also to access easily the HPC facilities for users using QCG now. You have a lightweight integration code also tools that simplify the usage of EasyVVEQ, as I said, like the merging with QCG and EasyVVEQ. So a lot of tools that really help you, as also with Muscle 3, to deploy your VVEQ campaigns easily on an HPC system. So a lot of resources from the project. You have the M36 version, which was released a few days before the Teratec Forum. You have a lot of documentation, a lot of training, a lot of tutorials, a lot of information. So please, if you're aware about VVEQ, if something that makes sense for you, that you have in mind to start this kind of activity, or already this kind of activity, you have a lot of resources available. So please take a look at this information and we'll find, I'm sure, what you need. Just one or two words about what Ethos Center for Excellence in Performance Programming does and how we contribute directly to this project is to focus on the performance and scalability of the toolkit and different components here. The two most important components we focus on are the QCG pilot job. So here you can see the hierarchical architecture of this tool. The idea is really to have this architecture to be able to be scalable, flexible, but also to keep really performance oriented access to the resources. And here you can see on the right the time required to submit a lot of jobs. We talk about ensemble size with FabSim 3 and QCG pilot job, and the idea was really to speed up this by prioritizing the launching of the different jobs, and we really gain a lot of performance here. So please, again, if you're looking for new scientific innovation about VVEQ, if you want to really easily deploy your VVEQ campaign into an HPC system, please take a look at this. A lot of interesting materials. We can see tutorials, publication, newsletters, but also videos, a lot of things that you will be able to share. And please feel free to contact us if you have any question or just ask a question now. Thank you very much.
Thank you, Erwan. Thank you very much. I have a short question for you. You seem to have a lot of materials ready in this project. So what is the current status of the project?
Oh, we are running the last month of the project. The project will end at the end of this year. Okay. And it's why we have, my point of view, quite a major toolkit, which is really ready to be used. And hopefully, yes, it will fit with the needs from people that are doing VVEQ, let's say, for their the daily work.
Thank you. Thank you very much. Any other question from the public? I can't see any question coming because this is your last opportunity to ask questions to the speakers. No, nothing? Well, I'll give you a couple of minutes to think of new questions, and otherwise we will just close the session. So I would like just to share with you so yeah, it worked. So today we saw EasyWays, EuroCC, Lexis, Ligate, and Vecma. All those projects are exhibiting in the Teratec Forum virtual exhibition. So if you want more information, please visit them. I don't see any other questions coming, so I think we will just stop for now. I would like to end by thanking the speakers. Thank you very much. Thank you for this very interesting insights into your project. I would like to thank the audience. Thank you for following us during lunchtime. Oh, I have some questions. Okay, thank you. Well, thank you to Bastian. With projects every day, tomorrow same time and Thursday same time, and I will be back on Thursday. So thank you very much. Bye-bye.